So we are going to move on to question number 3. And thus we were given 3.1, given that our f of x is x cubed minus 3x plus 5, 3.11, determine the coordinates of what? The turning points of f of x. So we do understand this one is a basic question. Given our f of x, which is x cubed minus 3x plus 5, the first derivative occurs on a condition where, the turning points occurs on a condition where the first derivative is what? Equal to 0. So you are going to need the first derivative from here. Drop the power, that's 3x squared, and subtract 1. This is going to give us minus 3. That's a constant, which is 0 there. So meaning to say, by considering this condition, it simply means 3x squared minus 3 must be equal to 0. Then solve for x. All right? Taking the 3 to the other side, that was going to be positive 3. Then divide by 3. X squared is equal to 1. So find x, guys. Simply find the square root of 1, which is plus or minus 1. So meaning to say we have got the x values representing our turning points. Where x is positive 1, what is the value of y? And the second turning point where x is what? Negative 1, what is the value of y? So we simply substitute into our original function f of x. When it is 1, substitute there in place of what? In place of x. That was going to give us a positive 3. All right, so this is positive 3. And when it is negative 1, you're going to obtain a positive 7. So these are your turning points. All right, then after that, draw up a table. All right, and our table is taken from what? Our table is taken ranging from what? Minus 3 to positive 2. All right, so minus 3 to positive 2, we just substitute into that original equation that we're given. All right, so that's 3.12. All right, so our table from minus 3 to what? To positive 2. Let us just, I'm just going to put a small table. This is x, this is y here. Minus 3, minus 2, minus 1, 0, 1, 2. All right, so that is what you're going to have. So you're going to simply substitute, guys, into that original function f of x when x is minus 3. So minus 3 cubed, minus 3 times minus 3 plus what? 5. Substitute properly in brackets like this on your calculator. All right, so that was going to give us negative 13. Minus 2 was going to give us positive 3. Minus 1 was going to give us positive 7, 0, 5, 1, 3. 2 was going to give us 7. All right, and I want us to notice something that is common here. That is common. Are you seeing that we have got the 0.13 as a turning point? Here on our table, we have got 1, 3. X is 1, Y is 3. So that 1, 3 represents what? Represents a turning point. We have it here, guys. And also, minus 1 versus 7. We have it also here, minus 1 versus 7. So it is also a turning point that we can see on our table. It's just for you guys to visualize. Are you following what you calculated before? All right. Anyways, besides that, you can just mark your points, guys. When drawing the graph, it's not a problem. You discover that on later on. All right. So that was it. Then draw a neat graph f of x between these values showing the turning points on it. So I'm just going to have a sketch. We have the points already. So that's 3.13. We're going to need the graph. All right, so that's, we've got negative values here. We have got negative values. I'm just going to put a sketch, guys, So that's our x and that's our y there from 0 to 2, 1, 2, negative 1, negative 2, negative 3. And here we can just use maybe 2 for 6, 2 for 6. And that was going to be negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14 for us to accommodate negative what? Negative 13. So negative 3 versus negative 13. Negative 3 and negative 13 will be somewhere there. So you mark a point in between that. All right. Then minus 2 versus what? Positive 3. Minus 2, positive 3, somewhere there. So it was going to be here. All right. So that's somewhere here. Minus 1 versus 7. 7 is going to be in between, just somewhere like this. All right. So that's minus 1, 7. And remember, it's a turning point, this one. All right. 0 versus 5. 5 is somewhere here. 1 versus 3, this is 1, this is 3, somewhere there. You mark your point. 2 versus 7, this is 2, this is 7, somewhere there, here. So remember, it's a cubic function, and here the coefficient of x cubed, it's 1. That's a positive. A is greater than 0, so you're going to have a shape like this, increasing up. So that is the shape that you're going to have. But remember, we have a turning point, guys, here at what? This one. It is a turning point, and this one is a turning point. So it means our graph was going to be like this. All right? Yeah, something like that. So this is it to the turning point. All right. To another turning point. Okay, that's the problem here. No problem. Let me just redo. All right. To the turning point. So that's a turning point. All right. Something like this. Then this one is also a turning point. All right, something like that. So guys, you can draw something that is clean, clear, actually, more than this. All right. So here's just a sketch. So that's 1, 3, our turning point. And also there is another turning point here, which is at negative 1, 7. So that was it. That is our function. F of x, y is equal to x cubed minus 3x plus 5, the one that you were given. So it is just a sketch here that I have from the table, guys. All right. So you can draw something that is more clear than what I'm having here. All right. So let us move on to another part of our question. Given that x is equal to minus 2, 3 is an approximate root of the equation, this. Use Taylor's or Newton's method to determine a better first and second approximation of this root. All right, to 3 decimal places. All right, so a better approximation from our Newton's method. Remember, it is simply x of n plus 1 is equal to xn minus f of xn over what? The first derivative of xn, where in our case, we are going to take the first root as our approximate, that's 0, x naught minus 2, 3. So it means if we've got x naught, therefore in our formula, we're going to use x1, and this will be x naught. This will be x naught. This will be x naught. When our n is what? 0, this will be x1. So that is the formula for our x1. So meaning to say, what are we going to need? We are going to need x naught, which is the first one, which is already given. So we are going to need to substitute it here in f of x and also in its derivative. So our f of x is what? Our cubic, this one, the function that you're given, of which We have already dealt with this one before. Our f of x is what? X cubed minus 3x plus 5. And its derivative is going to be 3x squared minus 3. All right. So this is what it means, guys. At x is equal to minus 2 comma 3, our x naught. So you have to substitute in f of x. So it means f of minus 2 comma 3 is going to give us what? In place of x, substitute minus 2 comma 3. That is what it means in place of x. That was going to give us something like minus 0 267 to 3 decimal places. Then the first derivative, you do the same thing. On the first derivative, substitute what? Minus 2 comma 3 in place of x. That was going to give you 12,87 in place of x, just like this. 12 open bracket x squared. Oh, sorry, that's 3. 3 open bracket x. Our x is what? Minus 2 comma 3. You close it and square, then subtract 3. So this is what you're going to have, 12,87. All right. So you're going to substitute into the formula now to determine x1, the first one. Remember, they said the first and second. So x1 is going to be x naught, the first approximate that you're given, minus 2 comma 3, minus f of this, which is negative 0 comma 267 over what? The first derivative, which is 12,87. So that is, we're going to obtain something like minus 2,279. Just round it off this one to 3 decimal places. All right. So this is the first approximate. All right. Remember, they said the first and second. So the second one, it means we are now referring to x2. All right. X2, meaning to say here it's going to be x1 minus f of what? F of x1 over the first derivative of that x1. So we have our x1 here. So f of that, we must substitute back. We must substitute back into our f of x. So that's f of x1. Remember, this is it. Minus 2,279. Substitute this in place of x into your f of x, the original function. All right. You are going to get 0,00 something like that. But guys, I'm just going to take at least 2. I'm just going to use this, not to 3 decimal places. I'm just going to add some values there. It was too much. It was going to be something like this, which is fine. You can actually to 3 decimal places, it was not going to work because it was just going to be 0,00, of which, guys, is not going to work. So that's why I just add some values there. All right. Then on the first derivative, you do the same thing. For that same value of x, substitute into the first derivative, this one. So that was going to give us 12, something, 12,582. So these are the values that you're going to need to substitute this time to find our x2, the second. X1, as it is here, negative 2,279 minus f of x, which is 0,000236 over what? F prime, this derivative, 12.582. That was going to give us the same value as previously, minus 2,279 to 3 decimal places. All right. If it is like that, it is not a problem. You just have to take it as it is. You just have to take it as it is. All right. So these are the this is the simplification that you're going to have. All right. Just like that. All right. Let us move on to 3.2, working with rates of change. Right. But this is an application that happens when you're dealing with motion. All right. When you're dealing with motion, and this is linear motion that we have. A particle moves along a horizontal line according to this law, where s is the displacement in meters and t, and the time t in seconds. So, all right, let us look into our question 3.21. Calculate the displacement of the particle after 2 seconds. T is what? 2 seconds. So this is our displacement in terms of time, remember. So simply substitute in place of what? In place of t. So that's S2. If you want, you can write it as S2. All right. It is up to you. Simply in place of what? T, substitute what? A 2. 2 to the exponent of 3. In place of t, so this is 2 times what? 2 squared plus 3 times what? 3 times 2. In place of what? In place of t, we substituted 2. So that was going to give us 2 over 3 or 0.667 meters. Remember displacement in what? Meters. Just like that, you're done. All right, then moving on, 3.22, find the velocity at time t and after 4 seconds. All right, so we need the velocity at time t. The velocity at a given time is simply the first derivative of the displacement. So v is the displacement of that velocity, which is ds dt, or the displacement, the first derivative with respect to t, like this. That's your velocity. So you simply have to differentiate. All right, drop the power, subtract 1. So 1 over 3 times 3, that's what? 1. So it's going to be t squared. All right, drop the power, subtract 1. That's minus 4t. This is going to give us positive 3. This is the expression of our velocity. The velocity at time t, this is the one they are referring about in meters per second. And after 4 seconds, we are now given the time to say our time is what? 4. When our t is what? 4 seconds. What is the actual value of that velocity? In place of t, simply what? Substitute 4. So that's 4 squared minus 4 times 4 plus 3. So that was going to give us our velocity in meters per second, which is what? This was going to give us 3 meters per second. All right. It was just like that, direct as it is. So that was 3 point what? 3.22. 3.23. At what times is the particle at rest? So guys, when the particle is at rest, it means our velocity is 0 meters per second. There is no movement. So if you check the question paper used displacement, which is something that is wrong. The velocity is the one that we talk about, not the displacement. Yes, the displacement, when we are saying it is at rest, there is no movement. It means there is no movement, but displacement could, remember, displacement talk about distance. Let's say a car is moving, guys. It covers 1,000 meters or 100 meters, whatever that you have. It has covered this distance. Then it stops. Can you say displacement is equal to 0? No, you have already covered 100 meters. But you stopped at a certain point after you've already covered a certain distance. So you cannot use displacement, no. That is wrong. Even the TVET series on the textbook, for those who are using TVET series, you find there's a question that was like that, and they used displacement again being equal to 0. So now they're just taking from that question. It was an example. Actually, they just took this one as an example. They are using it like that. You see, guys, revision also. That's why I'm always talking about revising the memos. All right, not just to take from the textbook as it is. This one was just taken from a textbook as an example. And on that example, they used displacement again. All right, let me see. All right, I was supposed to show you that textbook, but now I'm seeing that. But for those on membership, I'm going to try to show you that mistake, and we must correct that mistake. All right, displacement cannot be used. Displacement cannot be equal to 0 that moment. At 0, you're saying there's no movement at all. But when we say at rest, it has moved a certain distance, then there's no movement now. So there's no change in speed. There's no movement. So we are saying the speed. If you check your car, that part of the speedometer, you'll be seeing what it will be at 0, 0, 0, 0. But that does not change the distance. You do not see the distance that you have traveled now back at 0. No, that cannot happen. You have already covered 5 meters. You've already covered 100 meters. But when you stop, velocity now, the speed, is the one that we can take note of, because when there is movement, it changes. But where there's no movement, it's at what? At 0. So that is the idea. All right. I'm going to explain more on that, and also, like I said, be part of membership. Going to add more on that, revisions also on this section. All right, that can help you guys to understand more. All right, so this is what you're gonna simply need. Already we have the velocity expression. We simply need to equate it to 0 when it is at what? At rest. So meaning to say t squared minus 4t plus 3 must be equal to 0. Then solve for t, just like that. This is just a basic quadratic, guys. Factorization can work here. The coefficient of t squared is 1, so you can just say for 2 brackets t and t. Factors of what? Positive 3, which adds up to negative 4. Which factors are we talking about, or products from our factorization? Focusing on 3 as a constant. What are the factors of positive 3? And these factors must add up to negative 4. Negative 3 and negative 1. Multiply this, you get positive 3. Add, you get a negative 4. So we need what? Negative 3 and negative 1. So that's equal to 0. All right, solving for t, to the other side is going to be positive 3, or t is equal to this one to the other side is going to be positive 1. So these are the times. T is supposed to be 3 seconds, or what? 1 second, for us to have velocity being equal to 0 at rest. Use what? Velocity, not displacement. All right, correct on that part, guys. All right, let us move on. Find the acceleration. All right, I'm gonna need velocity expression at time t and after 4 seconds. All right, so they need an expression first for acceleration, then the exact value when our time is what? When our time is 4 seconds. Acceleration simply represents the derivative of the velocity, the change of velocity. So that is dv dt, the velocity expression. You must differentiate it. But remember, velocity was taken from ds dt. So it means acceleration is differentiating this again. So you can use this formula. The second derivative of what? Of displacement, or simply the derivative of what? Of our velocity. So that's acceleration. Simply differentiate the velocity. Drop the power here. That's 2t minus what? Minus 4. So this is our acceleration at time t in what? Meters per square second. What about the exact acceleration after what? 4 seconds. Simply substitute the time that we are given. When t is equal to what? When t is equal to 4, what is our acceleration? In place of t, substitute 4. All right, that is it. That was going to give us 4 meters per what? Per square second. Remember the units. Remember, always remember the units. All right. So these are the applications of our differentiation, the applications of our derivatives. All right. So in case that there is a part that we have not yet covered, please, guys, let us use the comment section so that we can communicate. I might think that I've covered everything on the applications, but if you see the part that I haven't covered, or a topic that I haven't covered in your mathematics N5, that is the purpose of the comment section. Let us communicate, because sometimes I might think that I have covered all. There are so many videos that we are working on, but your requests also, they are important. So this is it, guys. Basic questions. It's all about revision. So let us add more questions to this. Revise as much as you can.